Text preprocessing is one of the most fundamental and transformative steps in natural language processing. It's like clearing the clutter in your workspace before starting a big project, essential for setting a strong foundation. Raw text data as it comes is chaotic. It's riddled with inconsistencies like varying cases, redundant spaces, stray punctuation, typos, and even irrelevant sentences. Machines can't instinctively navigate this chaos the way humans do. To unlock the potential insights hidden in the data, we need to clean it up and organize it first. That's the job of preprocessing, and at its heart lies tokenization, breaking down text into manageable units that machines can understand. When we start preprocessing, one of the first tasks is standardizing the text. A word like apple written in uppercase might seem the same as apple in lowercase to us, but computers don't see it that way. They treat each variation as entirely separate entities unless we tell them otherwise. Lowercasing the text ensures consistency, and the variations of the word are all treated as identical. Next, we address punctuation. While commas, periods, and exclamation marks are helpful for human readers, they often don't add value for machines analyzing content. Removing them can simplify the data considerably, though there are exceptions. For example, punctuation can play a critical role in detecting tone or emotion in sentiment analysis. The way someone says a word with or without an exclamation mark can convey completely different meanings. Depending on the task, you might decide to keep punctuation intact. Whitespace is another sneaky problem. At first glance, it might seem harmless, but extra spaces, tabs, or line breaks can create inconsistencies in your data. Stripping away this visual noise cleans up your text and helps ensure that every piece of the input is processed effectively. By the end of this cleaning stage, you'll have text that's not only readable, but also primed for analysis. Once the data is clean, we move to tokenization. This is where the text is broken into smaller units called tokens. A token can be as simple as a single word, but it might also be a subword, a sentence, or even a character, depending on the level of granularity required. Word level tokenization is the most common approach, where a sentence like I love NLP becomes the tokens I, love, and NLP. However, even this seemingly straightforward process has its challenges. For instance, contractions like don't might be split into do and not, or left as a single token, depending on your tokenizer. Similarly, languages with no clear word boundaries, like Chinese or Japanese, require specialized tokenization techniques to determine where one word ends and another begins. For more complex tasks, word-level tokenization might not be enough. That's where subword tokenization comes into play. Subword tokenization is particularly useful when dealing with new or rare words that the model hasn't encountered before. Take the word unbelievable for instance. A subword tokenizer might break it into un, believe, and able. Even if the model hasn't seen the full word unbelievable, it can still understand its meaning by analyzing the subword components. This approach not only improves the model's ability to generalize, but also reduces the size of the vocabulary it needs to manage, which is a win-win for efficiency and accuracy. Another key step in preprocessing is simplifying words themselves to make analysis easier. This is where stemming and lemmatization come in. Stemming is a process that cuts down words to their root forms by removing prefixes or suffixes. For example, the words running, runner, and runs might all be reduced to the root form run. However, stemming is often quite aggressive, and the resulting root may not always be a valid word in the language. That's where lemmatization comes in as a more sophisticated alternative. Lemmatization considers the context of the word and converts it to its base form, or lemma, but ensures that the resulting form is an actual word. So while better might be stemmed incorrectly, a lemmatizer would correctly reduce it to good based on its grammatical context. These techniques are invaluable in tasks like text classification, where reducing word variations helps to focus on meaning rather than superficial differences. But in some cases, tokenization focuses on sentences rather than words. Sentence tokenization breaks a document into individual sentences, which is crucial for tasks like summarization or document analysis. Identifying sentence boundaries might seem simple, but it's not always straightforward. Think about abbreviations like Doctor or US. They include periods but don't signify the end of a sentence. A robust tokenizer needs to handle such exceptions intelligently, ensuring that sentence splits are accurate. Pre-processing and tokenization aren't just mechanical steps, they're deeply tied to the specific goals of your NLP project. Different tasks require different strategies. For instance, a chatbot might prioritize removing stop words, common words like the, and, or is that don't add much meaning, while a translation system would want to keep them because they contribute to the structure of the sentence. Similarly, tasks like text classification might benefit from aggressive preprocessing, whereas more nuanced applications like sentiment analysis require retaining as much context as possible. Understanding these nuances allows you to craft a pre-processing pipeline tailored to your needs. So what should you take away from all this? Pre-processing is the unsung hero of NLP. It's not flashy, and it doesn't get the spotlight that advanced algorithms or deep learning models do. But without it, nothing else would work. Pre-processing shapes how machines see and interpret language, laying the groundwork for everything from a simple sentiment analysis tool to a state-of-the-art language model like GPT. Mastering these steps isn't just a technical skill, it's an art. And as we move forward in this series, you'll see how each pre-processing choice you make ripples through the entire NLP pipeline, influencing the outcomes of your project in profound ways.